In this tutorial, I'll look at the encrypting file system known as EFS that Windows has used for many years. EFS is only available in the NTFS file system. FAT volumes such as FAT32, exFAT, they don't have any native encryption built in. EFS allows a user to encrypt files and folders so that no one except that user can access it. Well, what if a user loses their laptop? Well, anyone who finds a laptop can create an administrative account fairly easily with minimal hacking knowledge. Once this account is created, the administrator can make configuration changes and gain access to virtually any files that are on the hard drive. So if there's no encryption, a user's files can be viewed and even modified by any administrator who has physical access to this computer. An administrator can even change a user account's password. It's called resetting the password, and log in as that user. Well, if files are encrypted using EFS, will this administrator gain access to these files, even if they are encrypted using EFS? So to answer that, we need to understand the details of how EFS encrypts files. So this tutorial is designed to give you that deeper understanding. In previous labs, you've covered the basics of cryptography, and you should be familiar with the terms public key infrastructure system. Public key encryption uses what's called an RSA algorithm based on prime numbers to perform the math operations necessary to encrypt and decrypt data using public and private keys. And we also briefly talked there about symmetric encryption, where information is both encrypted and decrypted using one key. The benefit of symmetric key encryption is that you can create a symmetric key encryption system so that the encrypt and decrypt times on blocks of data are about 100 to 1,000 times faster than in public key systems. So we're going to see the benefit of this in a few minutes. But to start our discussion, we're first going to talk about hash and hash functions. Because hashes are used in the EFS system. So a hash is a one-way encryption system algorithm designed to only encrypt things in one direction. The common, probably the most widely used hash encryption system is called SHA for Secure Hash Algorithm, and it's used by the United States National Security Agency. Now, one of the major applications for hash would be in password use in systems. So if we have a password system and we're logging in, we obviously have to put in a password. The system has to check that password against something. Well, if we just stored the password in what's called plain text, anyone could go in and look at the password files and gain access to everyone's passwords. So that's not what's done. So let's look at a system up here. A user has generated a password called hello, and that goes through a hash function. And so the hash function is going to basically encrypt that and create this long hash. Now you also hear the term salted hash. That just means adding even more randomness to it. But we have this long hash, and instead of storing the password, we store the password hash. And remember, it's designed so it's virtually impossible to go the other way. That is, from the hash, go back to a plain text or clear text password. So now someone else logs into the system and they try the password world. They go through the same hash algorithm, and what comes out is a hash. Now this hash is compared to the hash from the word hello that is stored on the computer, and they don't match, so access is denied. So we can safely store hashes, password hashes, in the computer, and still no one, because the hash can't be reverse engineered, the passwords are still secure. So this hashing algorithm is a big part in many encryption systems and security systems. Now we're going to look at EFS, and what we'll first look at is how EFS actually works inside a Windows system. So here we have our Windows computer, and we have a file in a folder called test, and this file is just called test.txt. And if we look at the properties of this file and go to advanced, we'll file under the advanced attributes. There's a little checkbox here that says encrypt contents to secure data. And we're going to go do that. And once we do that and apply it, we'll get a question, encrypt the file in its parent folder. We're just going to say we're going to encrypt the file only. And hit OK. Now we will notice that by default Windows turns file names green. And we will also notice that we have full access to this file. So it is encrypted. Whenever I log into this account, I still have access as though it were not encrypted. But we're going to see that no matter what, no one else can access this file. Even if an administrator breaks into this account and changes my password, that administrator will not be able to get into that file. Now, as part of this system, there's also in Windows something called a certificate manager, and we can access it a number of ways. It is a Microsoft Management Console with a certificate manager snap-in, and we can bring it up just by typing that at a DOS box. And what you'll see here under the personal folder is that you have some certificates, and the logged in user here is called Joe Burridge. And we'll try to expand this a bit. And this certificate will not exist, or typically it won't exist until you actually use the EFS system. But you'll notice under intended purpose, encrypting file system. So this certificate gets created. This has your public key, but also a private key gets created, and we'll talk about the public and private key. And this certificate is used with the EFS system. Okay, we'll go back now and look at how EFS works in detail. So EFS uses more than one encryption system, and this is actually pretty common in data and communication security, anything that uses digital data. And what EFS is going to use is a combination of symmetric keys and public keys. And so we're going to look at an example here. So we have our file, and when I check the encryption box, that file got encrypted with a symmetric key, and it automatically created what was called a file encryption key, or FEK, and that is a symmetric key. And we said it uses symmetric keys because it's very quick. Remember, if we want to encrypt whole folders and lots of files, a symmetric key can encrypt about 100 to 1,000 times faster than public keys on large blocks of data. Now, some algorithms that Microsoft may use here could use a bunch of different algorithms. The US government used to use something called AES, US for an encryption system, a symmetric key encryption system. DES is currently used, and there is actually a triple DES because computers continually get more powerful. The encryption systems change so that computers can't defeat them. And Microsoft is using a version of this called DESX, so it's based on the US government's symmetric key encryption system. And what happens is we get a file here which is encrypted and no one can see. Well, we then need to store, though, the file encryption key. So it's no good having this encryption key able to be accessed by anyone, because they can just plop it into the same algorithm and go in the reverse direction, because in symmetric key the same key is used to encrypt as it is to decrypt. Well, what happens next is that this symmetric key, called the file encryption key is itself encrypted and stored with the encrypted data. And here's where we use that certificate I just showed. So now we're going to use public key encryption, and we're going to use the RSA algorithm to actually encrypt this using, if you looked in the example, it was Joe public, using the public key. So this file encryption key gets stored with the data, but it is encrypted using the public key. And because it's encrypted with a public key, we can't decrypt it unless we have the private key. So there is a certificate that was stored for Joe Burridge here, and that stores the public key, and it also created or pointed to a private key. Well, one question again is going to be, well, if an administrator can reset the password and log into that account, can't they go into the certificate store and access the certificate and therefore get the private key? No. In the certificate store, you can only get access to the public key, which is public anyway, which is no big deal. But the private key is stored in a special way, in a special location on the hard drive. And it itself is encrypted. And it's encrypted using a special Microsoft symmetric key algorithm. And it is encrypted using a special key that is not stored anywhere. The key is actually a hash, and one of the components of the hash is the password and username that the user uses to log on. And so every time a user logs on, a hash is created of the password and the username, and it creates a master key. But this master key is not stored anywhere, and it's generated every time a user logs on. So we have all these things being encrypted, the files being encrypted, and then the key to unlock the files being encrypted, and then the only way to unlock this key is with a private key, and that private key for the user is also encrypted. So here's what happens. Someone gets a laptop, an administrator, a hacker breaks into the laptop, creates an administrator account, changes the user's password, okay, and changes the user's password to something else, and then logs into that account. Well, that account is going to make a hash based on what the administrator used for the password, but that hash is not going to be the same hash, is not going to generate the same hash as the original user used, because the passwords are now different. And so this hacker that has an administrative account is going to create, yes, a master key, but it's going to be the wrong key. It's not going to be a key that's going to unlock this private key. And since we don't have the private key, we can't go backwards and generate the file encryption key, and if we don't have the file encryption key, we can't decrypt this. So Joe Burridge is the actual user. He does log on with the proper password. The hash is provided from the password username, creates a master key, the proper master key that encrypted this private key, and all of a sudden we get back the proper private key. Now in an RSA algorithm, the public key is used to encrypt, but to decrypt we need the private key, which we now have. And so we decrypt this, and we get our file encryption key, which we can then use in this system to decrypt all the files in the system which were used, which were encrypted using EFS. So this is an example of how EFS works, and it really helps to know the details, how these certificates work. if you're troubleshooting this process. So EFS uses a combination of many technologies to provide secure encryption of files and folders. Uses a hash algorithm to create a master key based on the login password and username. It uses symmetric key encryption to block encrypt large amounts of data, and it's using a symmetric key here because that's much faster than public key encryption. And it uses the public key encryption to encrypt the symmetric file encryption key. This can be a slow process because really we're just encrypting the key or we're decrypting the key, and we're only doing that once. So that's an overview of EFS and how it works in the Windows system.